Hello, we are moving on to the Black textbook, chapter 19, section B. We're going to talk about Pearson's product moment correlation coefficient, also known as R. In the previous section, we talked about subjective ways that you could describe the association between your numerical data, between your bivariate data. So we talked about correlation in terms of the direction, the linearity, the strength, or the causality. Those are all subjective terms. Pearson's product moment correlation coefficient, or correlation coefficient R, is a mathematical way to measure the correlation of the variables. So we don't have to just eyeball it and say it's strong anymore. We'll actually have a measurement. The equation is here. You will not have to use this formula. You will never calculate this by hand. You'll use your calculator. It has a way for you to do it on your calculator. But just so you know what it is, each data has two values, an x1 and a y1. And we find the mean of all of the x's and then the mean of all of the y's. And then for each data point, you subtract the mean from each x, and you get a number, and you subtract the mean from each y, and then you multiply those together, and then you sum all of those values. In the denominator, you essentially do the same thing, but you square them, and then you square root it. Again, you don't need to know how this formula works. You just need to know how to use your calculator to use it. But there are things that you need to know about what it means. So first of all, R will always be a number between -1 and 1. The sign of R indicates the direction of the correlation. So if it's a positive value, that's a positive correlation, whereas X increases, Y increases. And if it's a negative number, that's a negative correlation, so that as X increases, Y decreases. If R equals 0, that means there is no correlation whatsoever. And the absolute value of R indicates the strength or the confidence in your correlation. So the closer the number is to 1 or -1, the stronger the correlation. I told you all to use your textbook to look at this table, but I'll show it here. These are boundaries that you should be familiar with. So we'll start at the top. If R equals 1 or -1, then we have a perfect correlation. So positive would be a +1, negative would be a -1. If our correlation is between 0.95 and 1, we would call that very strong in either direction, whether it's positive or negative. If the correlation is between 0.87 and 0.95, we call that strong. If the correlation is between 0.7 and 0.87, that's moderate. If the correlation is between 0.5 and 0.7, that's weak. And anything less than 0.5 is very weak. So 0.5 indicates that there is 0.5 or greater indicates that there is some correlation, but anything below 0.5 is considered very weak. All right, so let's look at this first example. The Department of Road Safety wants to know if there is any association between average speed in the metropolitan area and the age of drivers. They commission a device to be fitted in the cars of drivers of different ages. The results are shown in a scatter diagram, and the R value for this association is a positive 0.027. Describe the association. So from this number, it is definitely less than 0.5, therefore it is a very weak positive correlation. So you would use all of those words. You would say whether it's positive or negative, and then you would describe the strength with one of those things, whether it was very strong, strong, moderate, weak, or very weak. As you look at this graph, this is just a scatter plot. So any of these points indicates a pair of data that compares the age and the average speed. So I just highlighted this one here. So for example, if I wanted to know what this data was, the person's about 75 years old and their average speed was about 40. I will do other examples later.